Hello everyone, this is Mohamed from Python Ninja YouTube channel. In the previous tutorial, we introduced Python iterator and how the iterator works in Python. In this tutorial, we will introduce Itertools, which is a Python module that is integrated with Python, allow us to extend the functionality of the basic Python iterator. The Itertools module in Python contain a collection of advanced tools for handling iterators. The iteratools are data type or the iterators as what we introduced in the previous tutorial. The iterators is a data type that can be used in for loop, or it's not like the data type, but it is like an object or like mechanism offer me object that I can loop within. Okay, the most common iterators are list, tuples, dicts, and strings. Okay, so I can iterate over list, I can iterate over tuples or dictionary or string, and I can build from this data structure, including list, tuple, dictionary, or string. I can build iterator object to loop over. Okay, in Python there is Itertools module, which allow us to perform advanced operation to the iterable object. For example, we can using the Itertools, we can perform product, permutation, combination, accumulate, sum, or accumulate a product. We can group the iterators or the items inside the iterators by any function we define, and we also can perform infinite loop, and there are three sub methods that can be utilized to have like an iterate over or apply infinite iterations over an iterators. And these methods include count. We can perform count to infinite, cycle. We can like swap among the items inside the iterator, and we can repeat some items. And we will start by introducing these advanced libraries. These advanced tools, which is introduced in a form of Python class, and it comes with Python, so it's built in. We will start with the product, so I will use it from Itertools. Itertools is a built-in, so once you will install Python, you will find the Itertools that you can import from Itertools product. Import a product. And we will have the first list, for example, list number 1. This contains numbers 10 and 20. The list number 2, just to understand the concept of a product, this will give me the Cartesian product between two iterables. We have, for example, here, let us to say 30, we have 40. Okay, and I have the result here will be nothing but the product that I imported. The product is not like a numerical product, it's the Cartesian product. The Cartesian product is or can be implemented using this concept. We have the first item, we like assign the first item to the second item, and we place them in a tuple, and we or a list. We can also place the 10 and 40 and plus. So you will have a result that you will have from the sum or from the product. So there is no arithmetic operation, but it's like kind of a combination. However, the combination is different than the product. So if I will apply the product of list 1 and list 2, and I will apply, I will print the result. This result will be a memory address that represents the location of this result object. So to have or to show this result, we have to unpack this to a list type, not to have the memory address or the object. Then we will see the result as it's represented here in this output. window. We have 10 with 30, we have 10 with 40, we have 20 with 30 and 40. So this is the product. This is the Cartesian product that will assign each item of a list or any data structure type. Here we will shift this to tuple, for example, just to show you that we can have the same result. What I will apply for a list is apply for the tuple, okay? And for the dictionary, you can like assign the dictionary keys and values. Now we have implemented the product as one of the advanced iterator tool. Remember that we can use some argument in the product itself. For example, there is argument called the repeat, and in this repeat, if we give the repeat every 2 items, so we will use 2 times, okay, to repeat or to perform the repetition to expand the combination of the Cartesian product. So repeat means that we do here the first combination between 10 and 30, and we repeat it again, okay? For some reason, if you want to repeat, you can use this argument, but the important thing is to know the idea behind the product that is provided with the Itertools, which is the methodology to perform the Cartesian product to have engagement between the iterator items. The next tool we will use, which is the permutations, okay? Permutations in definition or in mathematics, it returns to us all possible ordering among the iterable object, so or the iterable data type. So suppose we have here a list, okay? For example, I have list 1. Remember that you cannot use list, then you can assign them, for example, A, B, and C. So you are not allowed to use the same name here in Python, so you will have errors. Okay, so we use list1 or list underscore, for example. Okay, this is the best naming convention of variables because list itself is a reserved keyword in Python. Now I have a list. I want to see the whole permutation of this list. So as what I defined, permutation gives me all possible ordering. So this is the first order, A, B, C. I can have another order which is A, C, B. I can have another order which will be A or B, C, A. Okay, so if I will see here the identified result will be permutations of this list 1. Okay, and I will print the result as usual. So I will print the result. Remember that you will have the memory address. You have to cast it to a list data type to be able to print this. Now we will have a tuple, okay, or a list, because I have list here, and then I have the result itself is represented in tuples. I have a list of tuples that show me all ordering. Ordering means that the location or where is the index of each item, okay? So I have this as the first or the basic order. Then I have ACB. I changed the index of, or I swapped the index of C and B, and I changed the location. Then I changed also here, then here, then here. Then if you see the result, give me the all possible, okay, ordering, okay? I don't speak about the combination. I don't combine A, B, C together, okay? Because in the next example, we will show the combination. But here, the permutation is meaning that the ordering. So this is the basic order. But if I shift C instead of, or I change the location of C to B, okay, then this will give me the permutation or the order. So I can also here use, for example, the key which is represented here, and this key, if I pass the key to be, for example, 2, then I will have every 2 items, okay, I do the combination of every 2 items. So I do the combination, I do the permutation between A and B, then I do computation between A and C. As you see here, we do then shifting between B, A, we change the order. So this order A, B, then AC. This is the whole possible A, B, and AC. Then I change the order. I swap, okay, A and B, then it will become B and A. The same for B and C and the other items. Now, let us, so this is what I want to introduce for permutation. So we have a product for Cartesian product. We have permutation to show the order among the iterator. Okay, the possible ordering among the iterator. I will now introduce combinations. Okay, so suppose I have a list, and let us keep this list as the one we use in the permutation. And now I will have the combination, and I will see let us use the combination by default. Then we will have a problem, okay, because the combination, it should introduce an argument, additional argument, which is the length. Okay, for example, when I pass the length is equal 3, then I consider the whole 3 items. Then I will see here I only have A, B, C. Okay, this is the combinations between these items. But if I change this to 2, then I will have A, B, okay, because I consider the combination between every 2 items. I have A, B, then I have AC, okay, then I have BC. Only if you look to the permutation, okay, permutation will be different. So if I will have this one, okay, but instead of combination, I will have permutations, okay, and I will have permutation here. Then if you want to see here, for the combination, we only consider AB, okay, then we consider AC and BC. This is called combinations, okay? But if you go to the permutation, it considers this permutation, but it also consider it changing the order. It's swap, okay? So the permutation is combination plus it's changing the location, or it swap the location. For example, we have AB, okay, and in the permutation we have AB and BA, okay, which is this. Okay, and that's not allowed in the permutation. So in some application, you need to see the whole possible computation, the whole possible combinations. For example, you are interested in A and B, but you are not interested for some application in B and A, because if for example, we consider the summation, so the summation of 2 plus 4 is equal to the summation of 4 plus 2, okay? But if we go for coordinate example, for example, if you work in linear algebra and you are consider consider the coordinate, so the point 2 in x and 4 in y is not equal to the point 4, okay, in x and 2 in y. So it depends on the application. So just I want you to be sure that the meaning of a product is the Cartesian product, which is the possible combination between 2 iterable objects. Now we have the permutation. It allows me to do the combination, but it change also the order, okay, or to swap the location. And we have the combination itself, okay. Now, for some applications, okay, you can apply self-repetition among the elements. For example, what does that mean? Let us import here combination with replacement. Combination with the replacement, if you see, so I will delete now the permutation. If you look to this combination, A, B, A, C, B, A, sometimes you need to have combination with the self, okay, or with the replacement, meaning that we need to see also A and A, okay. So What does that mean? I will copy this example and I will use, instead of combinations, I will use combination with replacement. Okay, if you see the combination AB, AC, BA, then when I use combination with replacement, I will have A with A. So I will have like self-looping among A. I will have B and B, and I will have C and C. If your application is interested to have some of these or similar to this combination with replacement, you can use combination with replacement. If you work in like a vanilla applications, you can work, or like a general application that only need the combinations, you can use this. If your application is interested, especially specifically if you work in linear algebra and you are interested in the coordinate of a point in a space, for example, if you have x and y, then the permutation is introduced. But if you work, for example, in some application that if you use or do fusion between any two vectors, for example, the result of a fusion vector A and vector V, it will be similar to the fusion of vector V with vector A, because the fusion can be considered from like summation between these two vectors or multiplication. Okay. Now I think I introduced enough the permutation and combinations. Now I will go to accumulate. So this is a new. So they're both product combinations and permutation looks like similar, but with different utilization. Okay. Now I will use accumulate. Accumulate, if you have a list, for example, 1, and you have this result 10, 20, 40. Now, the accumulate means that I can add 10 to 20. Okay, so I start with 10. It will be the first item. The second item will be the summation of the first two items. Then I have the third item, the summation of the third three items. And I have the final item will be the summation of all. So if I can use accumulate to this list, okay, then I can print this accumulate. Then I will have again the memory address. I will have to and this to a list. As you can see, I have the first item is 10. Okay. Then the second item is the summation of the first two items, and the last item is the summation of the whole item. This is simply the accumulate and what can accumulate does. And the basic for the accumulate, it does a summation. But if you want to use, for example, instead of using the second item to be the summation, you need to see, for example, the product. So we can import operator module, okay, and I can append here like a function here, and the function could be operator.multiplication to have the result. As I introduced before, if you want to recall function, okay, inside a function, just remove these parentheses. And if you see here, okay, we use the function, okay, instead of summation. If I remove this, by default, it will be summation. But if I use operator.mul, which will be multiplication, the first item will be 10. The second item here is the multiplication between 10 and 20. 10 by 20 will be 200. And the third item is 6,000, which will be the multiplication between 200 and 30, and etc. to the last item. Sometimes if I will have like similar to this list, okay, I have 1, I have 2, I have 6, I have 4. This is just random guessing number. I have 4, I have 5. If I will use, for example, the function, okay, to be max, this what will give me? This will give me, it will compare every two items. Which is the max? 1 or 2, then the second item will do. So the first item is the first item, no change. The second item will be the conversion between 1 and 2, and this will be 2. The third item, which will be conversion, who is max? 2 or 6, then it will be 6. The third item, who is max? Okay. Sorry, we compare with the result itself. We don't compare with the list. So we consider the first item here. Then we compare, okay, between 1 and 2. It will be 2. then I compare 2 with 6, who is max? It will be 6. Then I compare 6 with 4, who is max? Then it will be 6. Then I compare 6 with 2, who is max? 6. Then I compare 6 with 8, who is max? It will be 8. This is the whole implementation of accumulate. Now, if you have iterable object and you want to group, okay, this iterable object based on a specific function, we can use a group by. A group by is also widely used in data science, and you can find this in pandas library. We will introduce pandas later. Just I want to finish everything about Python. Okay, so what can a group by does to me? Suppose I have the same list here. List number 1, I have item 10, 60, okay, 50 and 60. Okay, group by can filter or can group to me this iterable object, and again, what is applied to list can be applied to a table directly. It allows for me to group this iterable object into 2 groups. It will collect this into it will give this to 2 subgroups based on the function that I will have. For example, if I will have like a GRB or a group by, this is the group by that I imported now, and I want to group by my list. But this requires additional argument. I want to group by my list, but by what? By a function. Here I need to introduce the function. We learned together lambda, and lambda apply the anonymous function. It will take the input x. The input x will be this number. Okay, or sorry, this will, it will be this each of this number. Okay, and then it will say x. Okay. For example, if I want to group them by the lambda function, and this lambda function will check if each item here is lower than 30. What can I do? If I will print GRB as a group by result, then it will be a iterable object, and this will give me like two keys and items. Okay, I will have I will have to loop through this GRB to extract the result. So I can say for the key and value in GRB. Okay, what I can do, I want to print this to item K and V. V here itself is a memory address. Okay, so I have a true and false, but I want to unpack this. Okay, to be something like this. Okay, now the group by gives me here two iterable objects to loop by. Okay, or it gives me a iterable object but with 2 items to unpack. So we can unpack them here. Now the key, which is just the filter result, true or false. So I have the V or whatever you can name. This will be the group data. Okay. Now I have it true because 10 and 20 lower than 30, but I have false because I have 30, 40, 50 greater than 30. So this is the meaning of a group by. I group data based on function. Okay, for example, lower than 30, greater than 30, based on black, white, based on whatever the category is. Remember that we can repeat this implementation by using the ordinary definition of a function. For example, I can define, for example, filter GRB. This will take the number and just it will return if the number is lower than 30, and I can do the same thing here. I will copy all these. It will give me the same result, but here the key will be the new function, which is filter by. Remember again, when we recall the function inside another function, we remove these parentheses. When I run this, then I will have it true and false, and the same result can be obtained using the vanilla function. okay, or definition, or the general function footprint, or we can use the lambda, which is recommended for the function that consider multiple arguments and give me one result. Okay. Now, I will give you another example for a group by, just to be sure that you understand it very well. Okay, so I just move my keyboard. Okay, now look to this example. Suppose you have items, okay, and these items are represented in a list, okay, and this list will comprises different dictionaries, and inside each dictionary, let us to see, because I will give here for let's give it items, and inside this I will have the item itself, okay, then I will have the string, okay, and I want to copy all of these. Now to repeat this, then I have category, okay, and the category will be also like this. I will repeat, okay, this, okay. Now I will have this item, okay. I have items. Inside the items of list, I have dictionaries, and I have two keys, and I will have two values. For example, I have orange, this of a type of fruit, okay, and I will have here, for example, onion, and this of a type of vegetables. I will have similar here banana. I will have here fruit. The same thing for carrot, and this of the vegetables. Okay. So suppose I have this list of tuples in a grocery, for example, and I want to group the items, okay, inside this shop into group and into fruits and vegetables only. Okay, what I can do, I can grb, for example, group by function, which will perform a group by. So this list for this items, sorry, and the key will be here nothing but lambda. Lambda will take x as an input, and it will take also from x. It will give me the filter here will be the category. So this is very, very simple. So we pass this or the whole iterable here, and we select just the category, this key, then we will group this by key. For example, for key and V in GRP, okay, or this is just the naming convention. I will print K, and I want to print the list of V. Okay, and if you want to make it more fancy, you can, for example, add like this. Okay, just to keep everything going well. Now, if you can see here, we have the key, and we have the value, we have the fruits, and inside the fruits I have the items. Okay, we have the orange, and inside the vegetables we have also the vegetable items. Okay, then it will give me, if I will consider, for example, instead of having this form, I want to unpack, for example, from this list. If I use the index operator and that's 0, then I will have this dictionary. Okay, add this. So I have the first item is a fruit, and this is the whole dictionary. But this is also still not good representation to me. From this dictionary, I can pass another index operator here, and I can select the item type of itself. For example, if you want to item type, then you can see fruits. In the group of fruits, we have orange. In the group vegetable, this dictionary is classified to the fruits, and we have the item that is orange and vegetables, and based on onion we say vegetables, and the fruits in the last, in the penultimate one, and based on banana, and vegetables, okay, based on carrots. So this is other additional implementations. Finally, I want to introduce the infinite iterator. Okay, for example, count a function that returns an infinite loop that is increased by 1 each time we start. Let us import count. Okay, and I will say for I in count 10, meaning that we will start from 10. We like for loop from 10, okay, or while loop, but we start it from 10, but while loop will give me true and false. I will print I, then it will go to an infinite count, okay? So I want to stop this implementation. When we use this infinite, we use usually a condition to stop this infinite loop. So if I equal 20, then I want to break. So if you can look to this result here, we start from 10 and I have the condition 20. I can start even in negative, similar to loop from negative, in a range of negative number to positive number. So we can count from -1. So we can count 1 and like increase by 1. Like can be useful if you want to design a counter, okay, and at a certain point you want to break this counter. Another thing that I want to introduce is cycle, and cycle allows me to cycle, okay, among infinite iterable. For example, suppose I have the list of mine will be sorry, I have to have the list, okay. For example, it will be A, it will be B, okay, it will be C. So what I can do, I can say for I in cycle, okay, cycle of what? Of this list, okay. Then I can print I, but here the condition will be, for example, if the condition will be C, okay. So this can be used in gaming if you design the game, okay, and you want to see your chance. So like this ABC each time, but we can have the long item, for example, E, okay, just to see you. So we have ABC and we loop among this. If you remove this condition, okay, then it will be cyclic, okay. It will go A, B, C, D, A, B, C, D, A, B, C, D, okay. So this is the understand the or this is the concept behind cycling. The last thing that I want to introduce is repeat. For example, just look if we import repeat, okay, I can say for I in repeat, okay, repeat what? Repeat 1 to 4, okay. I want to repeat through this number, okay, and I can say like now I want to repeat, okay, which a specific value is repeated to infinite loop. I want to repeat 1. If I want to pass 4, then I can break this after 4 times. Just let us to see this implementation. So I can repeat 1 every time. So 1 is now repeated, okay? But I want to stop execution here. And after I want to pass 4, okay? So it will be stopped after 4. So repeat take 2 arguments, okay? The value that it will be repeated and how many times you want to repeat. Now, for example, if I will say, for example, my list, this is the last implementation for repeat. I will say, for example, welcome, okay. I will say wait if you like. If you want to design like something in the advertisement domain, okay, goodbye, okay, I will just repeat through this my list, okay. I will import time, okay, sorry, I import time and I will print I of 0, then I will give time to sleep, okay. For example, I will get this one. I will print I of 1, and I will take the similar time sleep here. Okay, and I will copy this, and I will take 2 when I represent show. It's show welcome, wait please, goodbye. So if you have like an advertisement board and you want to show something to this, you can use repeat if your text is like fixed or repeated, so you can do something like this. So this is the iter tools in Python, which is something that accompany with the iterator topic we introduced yesterday. And the next in the next tutorials, we will have some exercises related to iter and iter mature before going to next or advanced topics in Python.